So good afternoon guys. So in today's class we are going to concentrate on this thermal properties of matters. So what is the meaning of thermal properties? Like what is the meaning of thermal? So obviously when we talk about the word thermal, it is nothing but it is a heat. Yes, no? Like either we'll talk about heat or temperature, right? No? So properties of matter. Okay, when we talk about the properties of matter, like we are talking about like some atoms, molecules kind of things, right? No, so let's start discussing about what is the difference between this temperature and the heat. So there are like heat and temperature both are different quantities. Okay, so when we talk about the temperature, temperature is the relative measure of hotness or coldness. Okay, but when we talk about a heat, it is a energy, right? So the first point, if you see here, temperature is a relative measure of hotness or coldness. So hot utensils is said to have high temperature, right? Now when we talk about a hotness now, so obviously it denotes that high temperature, right? Now, and coldness, it is low temperature, right? So the SI unit of temperature will measure in terms of Kelvin, okay, and degree Celsius is the other unit, okay. Then heat is the form of energy which is transferred between the system and the surroundings, okay. So and this SI unit is joules. When we talk about energy, SI unit is joules, right? So heat energy, so it's a kind of energy, right? So SI unit is joules, okay. So the next one is like how we'll measure the temperature, okay, measurement of temperature. So we measure the temperature by using the thermometer. So obviously when we are in low classes or in small ages now, so obviously we will get a fever kind of thing. So when we go to doctor, obviously we use a thermometer to measure the temperature. So by seeing the temperature, he can decide that it's a high temperature or low temperature, right now. So it's a normal temperature or high temperature, they will say. It's not a low temperature, they used to say. So thermometer is the device which is used to measure the temperature, okay. So two fixed points are needed to construct the thermometer, okay. So what are those two fixed points? One is freezing point and other one is a boiling point. So when we talk about a freezing point, it is a ice point, okay, and boiling point is a steam point, okay. So this freezing point is taken as lower fixed point and this boiling point is taken as higher fixed point or upper fixed point, we will say, okay. So the lower fixed point and the upper fixed point. So when we talk about the divisions now, so for the Celsius, degree Celsius, so the divisions are from 0 to 100, in between that. So 100 divisions are there, okay. So we will talk about that formula also in this case. So measurement of temperature, two temperature scales. So one is Fahrenheit scale and another one is Celsius scale. So first one Fahrenheit and second one is a Celsius. So when we talk about a Fahrenheit scale, the ice point is 32 degree Fahrenheit, and when we talk about a steam point, that is boiling point, okay, this is 212 degree Fahrenheit. So what is this difference? Difference in the sense it's a subtraction of the two quantities. So 212 minus 32, how much we will get? 180. So 180 divisions are there in the Fahrenheit scale, whereas the Celsius scale, it is 100 degrees is the upper fixed point, that is a boiling point or a steam point, and the ice point is taken as 0 degree, okay. So total how many? 100 minus 0, right? So obviously I will get 100 only, right? So 100 equal intervals are there, got it? And the relation between the thing, okay, Fahrenheit scale and the Celsius scale. So whenever we want to find any unknown terms, okay, keep the unknown term in the first one. So the next one minus the lower fixed point, lower fixed point divided by the upper fixed point minus lower fixed point, okay. The thing I need to find, I will keep it as first point minus the lower fixed point divided by the upper fixed point minus lower fixed point. So what is the Fahrenheit scale if I talk about? F minus lower fixed point is 32, right? So 32 divide by, and what about this? Upper fixed point is 1, sorry 2 1 2 1 2, no, 2 1 2 minus what is lower fixed point? It is 32. Yes, no, 32. Right, should be equals to whatever thing we are taken to comparison. So we are talking comparison of the Celsius scale, right? So similarly Celsius scale, Tc minus what is the lower fixed point? It is 0. 0 by what is the upper fixed point? It is 100 minus 0. Got it? So what I should write here? C minus 0 divided by 100 minus 0. So what I will get? F minus 32 by 180 should be equals to C minus 100. So this is 1 times, and this is, I mean 0 0 will get cancelled. This is 5 times and this is 9 times. Got it? Yes, no? So when I take this 9 to the other side, F minus 32 will be equals to 9 by 5 times C, and where F is equals to 9 by 5 C plus 32. F is equals to 9 by 5 C plus 32. So this is the relation between the Fahrenheit scale and the Celsius scale. Got it? You can take a note of this. Done. So can we go for the next one? So the next one is, so the conversions. Okay, So temperature on one scale minus the lower fixed point divided by the upper fixed point minus the lower fixed point, right? So this is the conversions. Okay, so C and F. So most of the examinations will be asking this C and F only, Celsius and Fahrenheit scale. Okay, so the next one is the first question. Okay, let me take only the question, try to give answer for this question. I guess, okay. So what is the temperature which has the same numerical value in the centigrade scale and the Fahrenheit scale? Okay, this is the question. The question is asking when Fahrenheit scale is equals to centigrade scale, right? Na? Yes, no? Fahrenheit and centigrade are equal, then what is the temperature? So what is the temperature? Get it? Done? So first what you should do is write the relation between the Fahrenheit and the centigrade equation. What is the relation? F minus 32 by 1, so 212 minus 32 should be equals to C minus 0 by 100 minus 0, right? No? So what I told, the question is saying that when the, what is the temperature which has the same numerical value in centigrade and the Fahrenheit scale. So either I can take this as C or I should take this as F. Okay, get it? Or you can replace F and C with other term which is X or A or B, whatever term you want. Okay, so if I take X minus 32 by 180 should be equals to X by 100, right now? Get the value of this, the value of X I need here. So it is X minus 32 by 180 should be equals to X minus 100. So get it first, the value of X. That's it. So X minus 32 should be equals to 0 0 cancel, and this is 9 by 5, and this is X, no? Yes, no? Then cross multiply it, 5x minus, or else 5 times x minus 32 should be equals to 9x, right? Correct only, no? Get it? See, so x minus 0 by 100 minus 0, and then it is x minus 32 by 212 minus 32. So x by 100 should be equal to x minus 32 by 180. So when I take the cross multiplication, it becomes 9x. 9x should be equals to 5 times x minus 32. X minus 32. So this is 9x should be equals to 5x minus 160. 320 10 times it is 32 10 times it is 320, and then it is 5 times is 160 off of it, right? So 9x minus 4x, sorry 5x minus 5x should be equals to 160, minus 160, right? No, so it is 4x should be equals to minus 160, and this is 1 times and this is 4 times, so x should be equals to minus 40. So at 40 degree, 40 temperature 40 minus 40, okay? At minus 40 degree Celsius or minus 40 degree Fahrenheit, both scale are equal. Okay, this is the first question. Completed. So the next one. Okay. So the next question is, a thermometer as its lower and upper fixed points are marked as 10 degree and 80 degree. Okay, listen carefully. The lower fixed point and the upper fixed point. Okay, write the given terms first. So the lower fixed point, it is given as lower fixed point as 10 degree and upper fixed point is 80, right now. So when it is reached 38 degree, what is the corresponding temperature on centigrade scale? Okay, so what is the meaning of when it reaches 38? So the reading temperature is 38, but the given temperature like upper and lower is given as 80 and 10. Okay, so the given temperature is 38 minus the lower, it is 10, and it is 80 minus 10, right now 80 minus 10, and for which we should get it centigrade. No, centigrade in the sense C minus 0 by 100 minus 0. Got it? So this is the equation for this question. Get the answer for this question to find the value of C. So what is the answer? 40 you are getting. Okay, fine, we'll see. C you are getting as 40, we'll see. So whoever listening in online knows, so you can give answer in the inbox. We'll say see the answer. Okay, we'll check the answers. Okay, we'll check the answers now. So the answer is 40 degree Celsius. Okay, so x by 100 should be equal to 38 minus 10 is 28 and 80 minus 10 is 70, right? So when we cross multiply it, x by 100 will be equal to 28 by 70. So x 0 0 get cancelled off, x will be equal to 28 times 10 divided by 7. So this 1 times and this is 4 times now, right now, and 4 tens are 40. So 40 degree is the answer. Got it? Can we go for the next topic? Completed. So the next one is the ideal gas equation and the absolute temperature. Okay. So when we talk about the ideal gas equation, the equation should be PV is equals to nRT. Okay, in some books they have mentioned that it is a mu RT. Okay, both are same, like you can take it nRT. So where n is the number of moles and R is the universal, like a real gas constant, right now. So what is the value of R here? 8.314. Okay, 8.314 joule per mole Kelvin. Okay, that's the equation and the value of the real gas constant. Okay, and we will see the two laws here. So one is Boyle's law and one is Charles' law. So when we talk about the Boyle's law, it is PV is equals to constant, and Charles' law it is V by T is equals to constant, which means here if pressure increases, volume decreases, right? No, if pressure decreases, volume increases. Similarly, when I talk about the Charles' law, when volume increases, temperature also increases, right? No, so when volume decreases, temperature also decreases. So decreases, no. So use this equation whenever you are getting a question. Okay, so P is directly proportional to T, V is directly proportional to T, whereas T is inversely proportional to V. Okay, pressure increases, temperature also increases, pressure decreases, temperature also decreases. And similarly for volume also, if temperature increases, volume has been increased, and if volume is decreased, temperature also decreased. And it is vice versa of both of this. So if pressure increases, volume will be decreases, whereas volume increases, pressure has been decreased there. Okay, take a note of this. Done? So once you have completed, we can go for the next one. Okay. Okay, so we'll go for the next one. Yeah, so the comparison of the Kelvin, Celsius, Fahrenheit scales. Okay, so previous cases we have talked about the Celsius and the Fahrenheit, and in this case we will include this Kelvin also. Okay, so when we talk about the Kelvin, okay, Kelvin and the Celsius, okay. So Kelvin and Celsius, the relation is T, like temperature of Kelvin will be equal to temperature of Celsius plus 273.15. So you can take approximately the value as 273, and obviously we know the relation between the Fahrenheit and the Celsius. So if they are asking the relation between the Fahrenheit and the Kelvin, you can take this, okay, you can convert this. Temperature of Kelvin minus 273 should be equal to temperature of Celsius, and I can take this temperature of Celsius over here. So which is nothing but temperature of Fahrenheit will be equals to 9/5 times of temperature of Kelvin minus 273 plus 32. Okay, so this is the relation between the Kelvin and the Celsius and Fahrenheit and the Celsius. Okay, if they are asking the relation for these two, also we can get it. Okay, we can get it. Take a note of this 2 degrees Celsius and Kelvin and Fahrenheit. Done. Okay. Okay. So the next topic is the thermal expansion. So in this we are going to see the 3 types. One is linear expansion, areal expansion and the volume expansion. Before that, what is the meaning of the thermal expansion? So expansion, obviously we know that, so something is enlarging. Okay. So enlarging. What is the meaning of thermal? We are talking about the heat and the temperature. So obviously, so when we are talking about the thermal expansion, we are talking about the heat expansion, right now. So the increase in the dimension of the body due to increase in the temperature. So the substance expand on heating and contract on cooling. Okay. So these are the 2 important points. When the substance are expanding, no, it's because of a heat. So why it's expanding? Okay. So when I talk about a solid, no, solid in the sense obviously the particles are which is closely packed to each other, right? No. So when I give a heat to this object, what happens there? Like their energy will raise of yes or no? When I am giving heat to this substance, energy is rising and obviously there is a vibrational kinetic energy of a particle. Okay. So vibrational kinetic energy in the sense, when I am giving a heat, no, from a lower particle to the upper particle the heat are travelling, right now. So which means due to the vibrational kinetic energy the heat is travelling, it's energy, right? So it is travelling from one particle to the other particle. Okay. And because of that vibrational kinetic energy and the expansion getting happens. Okay, expansion getting happens, which means there will be a gap between each particle. Okay, the gap between each particle. So that's why we can expand the object. Okay. So the types is linear expansion, areal expansion and volume expansion. So linear expansion is nothing but in the expansion of length. Areal expansion is area and volume expansion obviously the volume. The term itself gives the name of 3 things: length, area and volume. Okay. So when I talk about a length, area and volume, it is 1 dimensional, 2 dimensional and 3 dimensional. Okay. So this is how we will classify the things of expansions. Okay. You can take a note of this and we can see the formula, how we can get the formula of the each terms. Okay. Done. Done. So the next one, so linear expansion. Okay, so usually when I talk about object, so let me talk about that object length is L. If I give temperature to that object, what happens there? The expansion takes place. Expansion takes place. So we have talked about this mechanical properties of solid. So when I talk about a change in length, like a length has been increased. So which means the strain has been increased. Strain is there, no? Strain is nothing but change in length by original length. What is change in length? Delta L by L. So this is delta L. So delta L by L. So why it is increasing? Because of the temperature. So directly proportional to change in temperature. Got it? So similarly we will talk for the areal and volume also. Delta A by A directly proportional to delta T. Delta V by V directly proportional to delta T. And to remove this proportionality, we are adding a constant called alpha, beta and gamma. Okay, we will talk about that alpha, beta and gamma. Okay. So linear, areal and area and volume. So three things. So linear due to length, areal A, volume V. So delta L by L directly proportional to delta T. To remove the proportionality, we are adding a constant called alpha. So delta L by L equals to alpha delta T. So this is the formula for the linear expansion. What is alpha? It is coefficient of linear expansion, and this coefficient of linear expansion, it depends upon the material. Like due to material it will changes. Okay, and when I talk about area, delta A by A directly proportional to delta T. And to remove that proportionality, we are adding a constant called beta. So what is beta here? It is coefficient of areal expansion. Okay, alpha, beta and gamma we will talk. Okay, and delta V by V directly proportional to delta T. To remove the proportionality, we are adding a constant called gamma delta T. So this is the equation and the formula for the linear, areal and volume expansions. Okay, and whatever expansion we are talking, it is due to only the temperature difference. Okay, take a note of this. And one more thing, so what is the SI unit of, like a unit of the alpha, beta or gamma? When I talk about the length by length or area by area and volume by volume, the unit will get cancelled each other, right? No, so length is meter, L is meter, meter cancel, area meter square, cancel, delta V meter cube, V meter cube get cancelled, but only T is left out. When I take T to the other side, like the Kelvin is the SI unit of T. When I take the Kelvin to the other side, so the unit of alpha, beta or gamma, it is nothing but Kelvin inverse. Okay, take a note of this. Done? Okay. So coefficient of volume expansion and aerial expansion, everything we got it right now. And yeah, I'll give a relation here. So the relation between alpha, beta and gamma. Okay. So alpha I'll keep as it is. But what about beta? Beta is nothing but 2 alpha. Gamma 3 alpha. Okay, this is the relation we will write it. So which is nothing but alpha is equals to beta by 2 equals to gamma by 3. Right now? Write it. This is a relation. So in questions, no, like they will mention, like in some questions or in most of the questions they will mention the value of alpha, but they will ask what is the area expansion or volume expansion. What I should do? I should convert that alpha as beta. Right now I should convert the alpha as beta, which means I should take beta should be equal to 2 times of alpha. If they are asking volume expansion, take that alpha and multiply by 3, that's it, you will get the value of gamma. Okay. Done? Okay. So yeah, so with this we'll stop the class for the today's session. Okay, and we'll continue with the thermal stress in the upcoming classes. Okay, so thank you guys, we'll meet in the next class.